I'm recording the class because I had some people ask. So the class is being recorded. I didn't mean to get off on a tangent. I just made a note to record. If I cannot fit this on Blackboard because it becomes too much, meaning the space, then I will find a YouTube page and I will post it on there. I don't foresee having an issue, but just in case. But this class is being recorded because some people did ask me if I can record this so that you guys can rewatch it. So I will make sure that that happens every week. Okay, so anyway, when we divide bases that are the same, we subtract the exponent. So multiply, we add, divide, we subtract. Very easy to remember. The next rule that we had was the property where, sorry, I'm just bouncing around here, any base raised to a 0 would be 1. And we discussed, when there's parentheses or when there's not parentheses and anything like that. Our next one that we had was if we have a negative exponent. So remember, one of the ways to remember this is a negative exponent will flip into the opposite part and it will become positive. So if it's negative in the top, it will go on the bottom and be positive. If it's negative on the bottom, it will go on the top. We're going to talk a little bit more about that in a few. Another rule that we discussed, so that was property number 4. Property number 5 was when we raise a power to a power. So we multiply the powers, but we also spoke about the fact that we don't want to forget about our coefficients. So if you have, let's say like number 5, oh no, I'm sorry, not number 5, that's over here. So here's the situation I was talking about. So this is the same rule, but now if you're raising a coefficient, which is the number in front to a power, you have to also consider that as well. Finally, we got up to here and I asked you guys to maybe look at this. So I'm actually going to take this last property and I'm going to merge it with property number 3, or excuse me, number 8, excuse me, and I'll explain why. So I'll, of course, demonstrate what's going on here. So if you're just joining me again, this is a continuation of lesson 2. We're going to wrap this up before we go over any homework. So number 1, or this property, I should say, is that when we have a fraction raised to a power, both the numerator and the denominator are raised to that power. So for instance, I'm just going to pick and choose here, or I can go through them. 2 over 5 in parentheses raised to the 2, both the numerator and the denominator are squared. Same thing with number 3, x and y are both raised to the 8. With number, let me just get these people that are coming in. I apologize, guys. So please bear with me for one moment. Thank you. For number 5, so we're raising x to the 3rd to the 5th. So we're multiplying those two powers. We're raising 2 to the 5th because, as I just mentioned, we want to raise our coefficient to the power. And we are also raising our y to the 4th raised to the 5th power. Okay, so that should be pretty straightforward. I want to remind you from last week that if we have a negative in parentheses raised to an odd power, our answer will stay negative. If we have a negative in parentheses raised to an even, it will become positive. Why do I bring that up again? Well, when you look at number 2, you have a negative being raised to 3, which is an odd power, so it should stay negative. We then raise 3 to the 3rd and we get 27. We raise 3 to the 5th and we get 125. Just as a hypothetical, I don't know why my internet, I'm going to
Your screen was freezing.
hold on. I am going to switch my router. Is that better? Can you guys hear me?
You're good.
Is that better? Yeah, I figured out what the problem was. I'm working in the downstairs part, so the router that I'm connected to is upstairs. So let me know. This should work now. Let me know if I get weird again. Am I good now? Yes, thumbs up. I'm gonna assume 10. Oh, okay. So I'm good. You guys can hear me? Okay, great. So if it gets weird, I mean, I'm always weird. I'll know what the problem is. I forgot to switch it. I got to make all these reminders on my brain. Anyway, thank you guys. So hypothetically, let's say it was -3/5 raised to the fourth power. Well, the 3/5 being raised to the fourth power would become positive because it would become a negative raised to an even, which would be positive. So I'll just make a little note of that. So if it was -3/5 to the fourth power, the answer would be positive. Just to kind of go with that. For number 4, 9 to the second power would be 81. And then b to the fifth raised to the second power would be b to the 5 times 2, which would be 10. And finally, for number 6, so we have a negative raised to an even, which is why the answer is positive. 3 is being raised to the 2, which is where the 9 comes from. 8 to the 11th is being raised to the 2, which is where the 22 comes from. 10 is being raised to the 2, which is where the 100 comes from. B is being raised to the 2, so that's b to the 2. And c to the 5 is being raised to the 2, which is c to the 10. So you're taking every component and you're raising it to that power, whether it be a coefficient, which is the number in front, or each particular variable. So I will take questions in a moment, but I just want to say a few things, and I'd like you guys to start working on the 6 that are there. It is 8:16 by 8:20 at the latest. I'd like to go over them. So for those of you that just came in a few minutes, we're going to go over the homework. I am recording this. It should be recording. So please know that I will post this. I probably will not post it till the morning, to be honest, because it does take a while to upload. But I will post this first thing in the morning for you. So no later than like 8 o'clock in the morning, you will have this. I moved your exam from the syllabus, so I've updated the syllabus. Your exam will not be this Monday, but it will be a week from Wednesday. And I'll write all of this down for you guys in a little while, because I know some of you guys like to take notes on that. So you know what? I'll write this all down now. So R300 homework 2 is due this Wednesday by 7:30 p.m. Okay. Sorry. Our 300 exam 1 will take place 3/24, which is Wednesday. I'll talk more about the exam in a little while. I always review for exams, so I will have a review sheet ready for you guys by this Wednesday. I think I'm going to post it tomorrow if it's ready. And then I'll have it for you guys Wednesday, no later than Wednesday. And we will go over it on Monday so that you can review. Most likely, I know you guys are working, but I'm just going to talk while you're working. Most likely on Monday, I'm going to start a new lesson. But whatever I do on Monday, I will not put on your exam. It will be the beginning of exam 2. So just so you guys know, the first exam will only cover lessons 1 through 4. Okay, hopefully that will help you guys a little bit as well. So 2 more minutes. Okay, it looks like the internet is, being a little better now. And then I have a few extra questions that I added. And if we feel good, we're then going to go and we're going to go over the homework. I'll also post the answers for the homework after I go over it. But again, this will all most likely be done in the morning. So please just understand, guys, that that will be done in the morning for you guys. So last 30 seconds and we'll begin. Remember that I like to go over it and then you guys can check and then I will open up for questions. So I do appreciate you guys staying muted and all of that. And then I'll open up for any questions at that point. So the entire 8/3 is being raised to the second power. So you guys should have got 64/9. Number 2 is a negative raised to an odd exponent. So the answer will be negative. 1 to the third is 1 times 1 times 1. 5 to the third is 5 times 5 times 5. So -1/125. Number 3 is going to be y to the 5th raised to the 10th, to the 2nd, which is y to the 10th. And then 12 raised to the 2nd, which is 144. Now we have a coefficient in number 4. So 4 raised to the 3 is 4 times 4 times 4, which is 64. X to the 9 raised to the 3 would be to multiply the two exponents. 9 times 3 would be 27. Y to the 4 raised to the 3 would be y to the 12th power. Number 5, a negative raised to an even power, sorry about that, will become positive. So I would maybe just write plus so I know it's positive. X to the 2nd raised to the 2 is x to the 14th, x to the 7th, I should say. 3 raised to the 2 is 9. And y raised to the 2 is y to the 2nd power. I'm only putting the plus just to emphasize the fact that it's positive. Finally, I have 3 on the 10. So 10 times 10 times 10 is 1,000. M to the 0 raised to the 3 would just be m to the 0. But remember, anything raised to the 0 power is just 1. So I'm just going to write a 1 there. It's not plus, it's times. So the whole numerator becomes 1,000. In the denominator, 3 raised to the 3 is 3 times 3 times 3, which is 27. And n to the 6th raised to the 3 is n to the 18th power. So at this point, are there any clarifying questions on 1 through 6? All righty. The last rule, which I didn't forget, but the questions got cut off, deals with a similar aspect, only you're going to add one more step. So this is kind of more practice of what we just did. So this rule says that if you have an entire fraction raised to a negative power, you can take the reciprocal or flip the fraction and the exponent will become positive. I'm going to demonstrate 2 examples just to show you, and then you guys can try my few examples that I have here. Why this is written here, I'm not quite sure, so ignore that. Sorry. All right, so let me demonstrate for you guys. So here's the first example. So if I have 2 over 5 raised to the negative 2, I notice that the entire fraction is raised to the negative 2. So I'm going to flip the fraction and the exponent becomes positive. So you're just doing a flip. 5 to the 2 is 25. 2 to the 2 would be 4. And that would be my final answer. So again, that always just makes, the most sense. Sorry, I don't know why my thing, it was my phone. Hopefully that makes the most sense there. Your next question would be a to the 3 over b to the 4 raised to the negative 3rd power. So again, because the entire thing is being raised to the negative power, I'm going to flip the fraction. So what is inside stays as is. And now my exponent is positive. B to the 4 raised to the 3 would be b to the 12. And a to the 3 raised to the 3 would be a to the 9. And I'd like to do just one more for you, and then hopefully you guys can try a couple on your own. So now we have, let's do 4a to the 4 over 3b to the negative 3 raised to the negative 1st power. Okay, so the next thing we are going to do is we are going to first flip the fraction. Now don't change the negative inside of the parentheses because that stays positive. That stays negative. Now, because we are raised to the 1st power, everything just stays as is. But if you remember, we said that we cannot have any negative exponents. So I'm just going to remind you guys, if an exponent is negative, I'm going to write neg for negative in the top put in the bottom. And if an exponent is negative in the bottom, you're going to put it on top. Meaning just put it in the opposite part of the fraction. So I'm going to let you guys get that down, and then I'll explain exactly what I mean a little bit more. So for instance, this b to the negative 3 is a problem. So I'm going to flip the b into the denominator, and it would become positive. Let me do one more just to seal the deal here, and then I'll take any questions you guys may have. So actually, I'll just do that right here. I'm sorry for jumping all over the screen here. I just am a little limited on my space. So let's try one more of those. Let's do 5a to the negative 3 over 6b to the 2 raised to the negative 2. So why don't you guys have that written for a moment? Okay, so first things first, this negative on the outside, I definitely want to get rid of first. I'll get rid of that by flipping what's inside, and my exponent becomes positive. Now I'm going to apply my exponent to everything. So 6 raised to the 2 is 36. B to the 2 raised to the 2 is b to the 4. 5 to the 2 is 25. And a to the 3 raised to the 2 is a to the negative 6. But wait a minute. This is a problem. Having a negative exponent will never be allowed in your final answer. So what I will do is I will flip that into the numerator, and it becomes positive. And now I have no more negative exponents. So that's what that rule means, guys. We do not want to have any negative exponents left in our final answer. So if it's negative on the outside of the parentheses, like these examples, flip it and it becomes positive. If it's negative on top, put it in the bottom and it becomes positive. If it's negative on the bottom, flip it into the top and it becomes positive. So 827 by 8:30, 31 or so, I would like to go over these. So if anyone has any clarifying questions at this point, please feel free to ask me, and I'm happy to help. If not, you're free to work. Indira, go ahead.
Would you be able to explain this problem again? It was too
Which one?
fast
The
for me.
last one I just did?
Yeah,
Okay, no problem.
I'm sorry.
No, don't. That's what I'm here for. There's no apologizing. And I'm glad you guys are just waiting for me at the end. So I'm going to start from scratch, okay? So no apologies. If you guys are working and you want to mute me because you don't want to listen, you can. If you do want to listen and work, you can. So one more time. This negative exponent is an issue. So I'm going to take care of that first. How am I going to take care of that? I'm going to flip what's on the inside. So all I'm doing is replacing the top with the bottom and the bottom with the top. Follow me so far? Indira?
Yes.
Okay, cool. So now I'm going to apply the exponent. That's the whole thing I just did at the beginning of class. So 6 raised to the 2 is 36. B to the 2 raised to the 2 is b to the 4. 5 to the 2 is 25. And then a to the negative 3 raised to, remember, you're multiplying the exponents, is a to the negative 6. You with me there?
Got it.
Okay.
I didn't know where the 36 came from.
I'm
Took
so
me a
sorry.
while.
Let me finish it up anyway, no problem.
Okay.
So now this is good, this is good, this is good, this is a problem. I'm going to fix this problem by flipping it up into the top, because if something is negative in the bottom, I can put it in the top and it becomes positive. If it's negative in the top, I can put it in the bottom, just go the opposite way. And I put the A before the B because in math, and again, you guys will see this as we do this all semester, it's always appropriate to put the variables in alphabetical. If you don't, you're not wrong, but any multiple choice will always have that. Okay?
All right, thank you. I got
You're
it now.
quite welcome, absolutely. Another minute or so, guys, but if anyone else has any clarifying, I'll be happy to do that. We're gonna go right into the homework after this. And then I will go over the next lesson, okay? I see a thumbs up, so I'm gonna assume that's a good thing, or if you have a question, okay. Thanks, David. If you need me, please feel free.
Professor, quick
Yeah,
question. How did you get the 36b to the fourth power?
so 6 raised to the 2 is 36. Remember,
Oh,
second,
okay,
yeah?
got it.
Kind of answered your own question then. Hey, I love
Thank
that.
you.
It always makes me smile. All right, you're welcome. So number 1 or letter A, this is our problem. So we are going to write this as y over x raised to the 3. Now that my exponent is positive, I will get y over to the 3, excuse me, over x to the 3. That one should have been pretty straightforward, I think. Next one is going to be, Marion, I'm just going to mute just if you don't mind, but don't think I'm being rude. The next one is going to be, so again, this exponent being negative is going to be c to the 4 over a to the 2 raised to the 4. So c to the 4 raised to the 4 is c to the 16. A to the 2 raised to the 4 is a to the 8th power. The next one, again, negative exponents are a problem. So 5y to the 3 over 2x to the 2 raised to the 2nd power. So 5 squared is 25. Remember, it has to go into both, guys. And this is a very honest mistake. Maria, I'll be with you in a few. Y to the 6th on top. In the bottom, 2 raised to the 2 is 4. X raised to the 2 is, I'm sorry, x to the 2 raised to the 2 is x to the 4th power. Finally, the last one. So again, this negative exponent we want to eliminate first. So we will just rewrite everything by flipping. Anything raised to the 1st power is just itself. So 7b squared over 6a to the negative 3. Your final answer cannot have a negative exponent. So because this is negative, we will simply flip it into the top and it becomes positive. Go ahead, Maria. I'm ready for you and then anyone else that needs me.
Sorry, I just have a question on the
Stop
B.
saying sorry, you guys. Go ahead.
I
No, sorry. This is new stuff.
I have a question on the B. So I got C 156. So my question is,
I know what you did. You're raising 4 to the 4,
yeah,
which means you're doing 4 times 4 times 4 times 4. But what really is happening is in C, I'm just going to write it down here because of space. What's really happening in C, forget the negative right now, okay? So what's happening is you are accidentally doing this, okay? But it should just be 4 times 4.
So I'm multiplying.
Yes, you are raising a power to a power. That is this property right here.
Okay, but how about if we have square is the same?
Everything is the same. I think the confusion, and this is good lesson for everybody. I think the confusion is coming in here. So let's say I give you guys this. Okay, let's just stick with this for now. Let's not even make it a fraction, right? So when you cube 2 to the 3, it's 2 times 2 times 2, which is 8, right? But this does not mean 5 times 5 times 5. This means 5 times 3.
Oh,
That's the difference.
okay.
Okay. So when you're raising the coefficient to the power, you're multiplying the coefficient by itself that many times. But when the variable is being raised to the power, you are multiplying them. And that's going to take a little bit of practice on your end.
Yeah, okay.
Okay. Nazar, you're next. I just can't hear you, Nazar.
Amos,
Oh, go ahead. Thank you.
so is it me or you on D? Was this supposed to be 7b to the power of
Okay.
2 and then
Talking about?
that's
Oh, D?
yeah. Wasn't it supposed to be 7 B to the power of 2? I think you flipped the 7. You see how the 7 was supposed to be 7B? Or is it me?
Okay, so let's do it. So 6A to the -3 over 7B to the 2. The negative was the problem, right?
No,
Let
I'm
me-
just talking about the final answer.
Yeah, I want to follow it, make sure.
Oh,
we're
okay,
correct.
okay, okay.
So that means that we flipped the fraction and it got raised to the first power, correct?
Right.
Okay, I just want to make sure. Listen, I can make
Yeah.
mistakes too. It happens, especially all day teaching math. And not that it's an excuse, but I'm just being honest. So now we have 7B to the 2 on the top and 6A to the -3 in the bottom, right?
Mhm.
Okay, this -3 has to go up in the top because of the fact that it's negative, and we always put our variables in order in alphabetical. So I'm
Okay.
not sure which part you're missing, but that is the correct answer.
Oh, so you just so you just flip the A with the B because you're going okay. Okay.
Right, the 6 is not the issue, it's
Mhm,
what's
mhm.
being raised to the negative that is. I could write the answer, I think this is
Yeah,
what.
yeah, yeah. That's what I got, and I got
That's what I
confused.
had
But you just
mentioned
put it
earlier.
out.
Yeah. You can
Yeah.
write, let me just be honest with all of you.
I just
You
don't want to be confused.
You can write your answer this way. This is not wrong. The only thing I want to warn you guys about is if this was a multiple choice, you would not see the answer that I just wrote. You would see the one in the box. So you can write this as your answer. You just have to make sure you can match it to the multiple choice. Remember, I don't give you guys multiple choice in class, but on a final or an exam, it's multiple choice. And so you might get 7B squared A to the 3, but in reality, the answer will see 7A to the 3B to the 2. Okay, but yes, you're still correct. So I think that hopefully clarifies. All right. If
I
there's
have a
anything-
question.
okay. I'm going to take this last one, and then what I was going to say is I just don't want to backtrack on time. Marianne, you can totally ask me. So what I'll ask is if anyone still has anything on this lesson, just make a note of what your question is, and after class you can stay on, and I will help you. But I just want to keep minds of the time because we're already at the 8:40 mark. So Marianne, and then I'm gonna just open the homework in a moment. Go ahead. I'm sorry.
So a question, should we notate, a rule is to keep the variables in alphabetical order?
I
Does
mean, you can write that in your notes. It really is in theory, it is
Oh.
the correct thing to do. I'm not gonna nitpick on you about it. I don't really know any professors that would. But it is important to write your variables in that order. So I would say it's a good idea only for the simple fact that if you I didn't mean to stop sharing. If you don't do that, let me just reshare. If you don't do that, what might end up happening is maybe you get confused later on. So I would just make it a thing to do because then you'll just always do that. You know what I mean? Like I would just say, yeah, if you want to make a note of that, do that for yourself. Okay? Couldn't
Okay,
hurt.
thank you.
Yeah, of course. It can only, help. All right, I will post those notes for you guys after. So let me talk about how I go over homework. I had a few people that were a little confused about how my homework was written the other night. So let me just quickly explain what's going on here. So guys, the homework is from the textbook. So these mean the pages, just in case anyone does have the book. These stars just meant that they came from a different source, not in the textbook. Sometimes I will give you multiple choice, sometimes I will give you open-ended. Some of you guys reached out to me, and I'm sorry if I wasn't clear last time. So if you don't have a printer, you don't have to print this. I will just ask that you guys write your homework neatly. So you would do number 1, show the work, number 2, show the work, 3. If you want to print this and write on it and you have enough space, do it, whatever it is. Homework is not accepted via email because if I get 30 emails of a homework, my space runs out and then I don't get people's stuff. So please upload it on Blackboard, and the cutoff is 7:30 p.m. I have to be careful about that because what happens is I go over it and then it's not fair to other people who did this if you're just taking notes and submitting. So please keep that going, going forward. So I'm going to just quickly run through the homework. I won't rush it, but I want to move at a nice pace because I really do by 8:50 want to start lesson 3. Indira, I'll ask you to just hold your question for me and then I can get that afterward if that's okay. So which are not rational? So remember, rationals are going to be your integers, your fractions, your terminating decimals, your repeating decimals, your perfect squares. So we're going to say that -2 is rational. If you want to take notes as I write, you can. It is an integer. 3.584894 is also rational. It is a terminating decimal. Pi is irrational. It is one of our most famous. I'm going to tell you guys something interesting. There's always an exam question that comes up on the final, not all the time, but I've seen this, where they will say, which number is not rational? So they'll put 3.14, they'll put -5, they'll put 4.6, and they'll put 7.8293841, ... People, so the question is asking which one is not rational. And people always pick this, and the answer is wrong. 3.14 is a terminating decimal. Therefore, it is rational. Pi, which yesterday was Pi Day, so funny, I know the math nerd in me, is 3.14159 going on forever and ever. So it is a non-terminating, non-repeating decimal. So please understand the difference between 3.14, which is what we have been drilled in our heads to recognize pi as, and what pi actually is. So the correct answer here would have been this. This is a non-repeating, non-terminating decimal. So please be careful and don't fall in those traps. Anyway, so I'm going to go back to the original question. 3.040040004 is also irrational because it is not repeating. It looks like there's a repeating, but there's more of a pattern than there is a repetition. -3/5 is rational. It is a fraction. Radical 49 is rational. It is a perfect square. Radical 3 is a non-perfect square. So it is irrational. Somebody asked me about perfect squares. So again, if you want a list of your perfect squares, you should be familiar with these. You should have seen these in the past. So this is implied knowledge. I'll still write them for you guys. But these are your perfect squares. I hopefully didn't miss any of them, but I look like I'm good. So that's the answer there. So again, this was a multiple choice question. So the answer would have been B. Okay. So if you have a question, make a little note. And when I stop going over this, I will then answer all the questions I need to. Number 18, you had to change the fraction into a decimal. Remember that you guys are not allowed to use any calculators in here. So I showed you how to do this. This again is old knowledge. So this is long division, which I'm not going to reteach in here. Okay, if you're in this class, then you are assumed to know this. So I went over this the other night. We can subtract until we either see repeating, non-terminating, so it's all over the place, or a remainder of 0. So this would be considered a terminating decimal. You know what I'll do, guys? I'll write T, or I'll write NT for non-terminating, just so you can differentiate. For the next question, 17/3. So when we set this up, the 3 on the outside, the 17 on the inside, this is going to go in 5 times. This goes in 6 times. And I'm going to keep getting 20. So what you guys might notice is that you guys are going to have a repeating decimal here. So I'm going to write R for repeating for number 21. 0.666, it will go on forever and ever. 16/5 is an easy one. So 16 divided by 5 would be 3. I add my decimal and then I add a 0 to continue division. This is a terminating decimal because I end up with a remainder. Finally, 41 over 7. So 7 goes into 41. That's going to be 6, that's going to be 5 times, excuse me, for 35. So I add the decimal and then I add my 0 to continue my division. 60 divided by 7 is going to be 8 times. 8 times 7 is 56. Okay, so I still don't have a remainder of 0. This will be 5 times for 35. This is going to be 7 times for 49. So after you go about 4 or 5 decimals, if you don't see any repetition and there's no pattern and there's no terminating, you know that this is going to be a non-terminating decimal. Actually, it would be going on forever and ever. Oh, excuse me, not non-terminating. This is going to be, yes, non-terminating decimal. The next one, which is the stars. So the additive inverse just means to negate. So if it's -3 over 5, the additive inverse would be positive 3 over 5. The multiplicative inverse, so if we are given a mixed number, we must change it to improper. So this would be 17 over 5, but then we need to take the reciprocal. So the multiplicative inverse would be 5 over 17. So please note, guys, that this is the improper fraction. When we take the reciprocal, we have found the multiplicative inverse. Thank you for allowing me to keep going. Again, just make a note of whatever you need me to go over, and I will do so after. The next question, so this is order of operations. Remember that these are just a fancy way of saying another set of parentheses. I would put a dot here and a dot here to show the multiplication. So 9 minus 7 would be 2. I'm still inside of my initial parentheses. Then I'm going to get 3 minus 16 in the parentheses. And 3 minus 16 would be -13. Now, if you want to drop the parentheses, you can, as long as you know that there is multiplication next. 4 times 13, or -13, I should say, is going to be -52. And then -2 minus 52 would be -54. By the way, this is from M100, these questions right now. So understand, guys, that you need to make sure that the old material is fresh. Number 289, which is again from the textbook. So this is just another way of saying parentheses. So we're going to, of course, see that we have multiplication, but then we have division. And since there's parentheses, the division comes first. Okay, so you have to consider what is going on, and parentheses always come first. Next, inside of the parentheses, I will multiply my 2 and my 2. Then I'm going to get 5, and I can drop the parentheses at this point. This is going to give me -20, and 9 minus 20 is -11. I'm hoping, and please don't think I'm judging any of you because I can't see what you guys are doing right now, but you should be fine-tuning your homework at this point. So you've already submitted a copy for me, which I will merely look at for an attempt that you guys tried. You can get stuff wrong and still get credit. What happens now is that you guys are making any corrections that you need in order to really understand. And then what you do is you go and you review this stuff for yourself. The next 2 problems are going to be from not from the textbook. So again, these brackets are just a fancy pants way of saying parentheses. I'm going to rewrite this down here for a little room, and it is multiple choice. So I'm going to start with these parentheses here. I'm going to get 5 minus -4, because this is -4, 2 minus 6. I'm still inside those parentheses here. So this is going to become 9. And since I get a single number, I can drop my parentheses. I now have 2 multiplications. So this would be 25 plus 12 plus 2. This would be 39 plus 2, which it would be 41. Okay. Finally, for this last one, and then what I'll do is I'll take questions on this page. 3, again, we're inside of the parentheses, applying PEMDAS inside. 3 minus 13 plus 8 in the parentheses. 13 plus 8 would be 21, and 3 minus 21 is negative 18. So right now it is 8:50, and I will stop for a moment if anyone does have questions on this first page. Okay, so Maria? And then I think there was someone else. Go ahead.
So I just wanted to ask on between number 21 and 36, what happens if we just miss that whole number? Somehow I
Okay, so
didn't
for
make
the
it.
first homework, if you want to talk to me about that after class, I just want to stick with the math right now. So if there's any personal stuff, just stay on after and I can talk. If it's the first homework, I'm going to be a little lenient on the first. Going forward, just make sure that you notice all of them, okay?
Okay, thank you.
Cool, you're welcome. Was there somebody else I thought I saw a hand before?
I have a question.
Yeah, Marianne, and then I'll get Deanna. I'm sorry, I just caught Marianne first. So Marianne, then Deanna, go ahead.
On question number, the first one, you mentioned, I thought pi was irrational.
It is irrational. Irrational means not rational.
So pi is irrational.
Right. This weird
Um,
question that I made up on the side here, this 3.14 is not pi.
Right.
3.14 is a decimal that kind of we associate pi with. But pi, so not rational means irrational,
Right. Okay.
right? So pi, the 3.04004, and the radical 3, those are all irrational. Pi is that the most famous one. The 3.04004, whatever, there's no repeating and it doesn't have a pattern. And then finally for radical 3, it's not one of those perfect squares. Okay?
Okay. And so then 3.5894, that's not irrational at all?
No, because it's a terminating decimal. So remember, rationals are the following. I'm going to write the list one more time. I'll write it over here, and then Deanna, I'll get your question. And then if you still need me, if I don't clarify here, Marian, I'll just ask you to stay on after and I can clarify a little more. But your
Okay.
irrationals are your fractions. I mean, your rationals are your fractions.
Fractions.
Your terminating decimals,
Decimals.
okay? Your repeating decimals. Your perfect squares. Okay, your integers. All of those are your rationals. Your irrationals are your non-repeating, so it doesn't repeat, non-terminating decimals,
Oh, okay.
okay? And your non-perfect squares and all of that. And that includes cubes and all of that, but I don't want to get into that tonight, so. Okay, I'll also attach this page to the homework, so I'm not going to erase this. I'm just going to go with Deanna, and then I'm going to go to page 2. I don't mean to not get to.
Yeah, I'm here. I'm sorry, my Wi-Fi
that's
is like
okay, go ahead.
crazy. So for number 36, where it was 41/7,
Mm,
I kept going just to double check, and it repeated itself. Like it started to repeat the numbers.
Okay, let me
So
just
would that-
check because I didn't work this one. It should not repeat anywhere. So let me open my calculator on here for a moment. Because I only checked quickly with my other one, so just bear with me. I'll check with my calculator if I can find it on here. Of course I can. Oh, now I'm giving you guys my email. Lucky you. Let me just take a quick look here, and then I'm gonna go to the next page. If I have to revisit this one, where the heck is my calculator today? If I have to, I don't know where the heck it went. Oh, here it is. Oh my God, it's right in front of my face. Oh man, guys, I need a vacation or something. All right, let that open up a minute. Let me start going over the second page after, and then I can, well, it's opening. So it should not have repeated anywhere. I'm not sure where you saw the repetition.
I think the 857 came back.
Let me just take a look. 41/7. I'm cheating right now, by the way. 41,857. Actually, I made a little error. I'm so sorry. You are
Or
right.
should it be a non-terminating repeating decimal?
No, it's terminating. Let me explain
It is,
why.
okay.
I apologize. I went a little too soon here. So it's
No,
good.
it's okay.
No, it's okay. And listen, if I do that, that's me rushing. So my apologies. Let's go back to this one a minute, guys. So 30. And by the way, you would never be asked one of this caliber on an exam. I'm just being honest with you guys. So this would be 4. So this is 28. I'm just going to finish this up. So this is going to be 0. I'll share the other screen in a moment with you guys. I'm just going to finish up the division. There's only 3 more digits that I need to use. This would be, what is that? 7, not 7, 8, which would be 56. You would never even be asked anything of this caliber. So I'm just going to be so honest with you guys. 40 divided by, and I'll tell you why I made a mistake. And this was me rushing. Not that I'm giving you guys an okay excuse of me rushing, but I'll tell you why. So here's the issue. I'm going to show you right now. This is still a non-terminating, and I'll tell you what the problem becomes. The problem becomes, can you guys see my screen where I'm writing? I think you guys should be able to. The problem becomes that even though if you were to check your work on a calculator, the calculator screen is going to cut off at a certain digit. So let's go back for a minute. 41 over 7 is a rational number. So rationals will either be terminating or repeating. For number 18, I think it is, it terminated. For number 21, it repeated. For number 25, it terminated. So now if we were to continue the division here, and yes, you are right, Deanna, we would have that repetition occurring. So this is a repeating decimal. My apologies. So sorry about that. So I fixed that right now. Thank you for keeping me on my toes, but hopefully that makes a bit more sense. And what I'm going to tell you guys right now is I took this out of the book, which is why I don't love the book at times. It is a little bit of an intense problem. If any of you do have the book, you'll notice that there are a lot of problems that become way involved, which is why I cut and paste what I want to show you guys. But in any case, just so you're guys aware. So Deanna, I hope I did clarify for you, but I also want to thank you for doing that. So thank you.
No, you did, because I wrote a repeat
No, listen.
decimal on the homework. So I just wanted to make sure that
No,
I
you
was
are right.
understanding correctly.
You are right. You are 100% right. And thank you for that correction. I do appreciate it. All right.
Right.
Anyone else with anything on this page? I will get you after. It's already almost 9. I do want to get lesson 3 started. So let me just finish up with these, and then I'll take the questions and then we can go. So what you would want to do with this 62 over 99 is you would want to find a few decimal places to compare. So 62 does not go into 99. So I'm going to add my decimal point to allow the division to continue. This would have been 6 times. This math should have been done, which is why I'm not doing it. But that would be 594. So I gave you guys a little bit of a tougher number to work with. So that's going to be 620 minus 594, which would give you 26. Add a 0 to allow the division to continue. That would be twice for 198. So I can see I'm getting close to that decimal already. 260 minus 198 would give me 62. And obviously you guys can see that this will be a repeating decimal. I do not need to go any further because now I can see that 0.623 is going to be smaller than 0.626. So again, guys, long division, of course, is something you guys do need to remember. For the next question, I'm going to drop out the negative for a moment. And I'm also going to balance the decimals by adding a 0 to the first decimal so that it's the same number of places. So because there's a 3 in front, I'm looking at the 2260 versus the 2262. Obviously, 2262 is bigger than 2260. But of course, when it's 2 negatives, we make it positive for a minute. We decide, and then we flip the inequality sign to go opposite. For number 363, so again, you want to change this into a decimal. So this would be 0. I add the decimal to allow the division to continue. So this would be 2. This would be 2. And I don't even need to go any further for two reasons. A, I could see it's going to be 2, 2, 2, 2 forever and ever. But more importantly, I can see that this bar does mean, so this means that it's going to continue forever and ever. So if I compare negative 0.22 to negative 0.02 repeating, I will temporarily get rid of my decimals. I will then say that 0.22 repeating is larger than 0.02 repeating. But again, because it's positives and then I reverse the sign, I go back to the inequality for the negatives. Finally, pi is 3.14, obviously goes on, versus 3.16. So again, I'm going to temporarily get rid of my negatives. 3.16 is obviously bigger than 3.14, but because they are negative, I reverse the sign. This normally doesn't come up on the final, but I do like for you guys to know it. So just a heads up there. To find the difference in two numbers, we can take the absolute value of their difference. It does not matter the order. So we could do 10 minus 4 or 4 minus 10. I get the absolute value of 6, which would just be 6. For number 401, I would need a common denominator. The common denominator would be considered the least common, which in this case would be 24. So I'm going to rewrite these so they both have 24. The top and bottom gets multiplied by 4 to make that 20 over 24. The top and bottom gets multiplied by 3 to make that 9 over 24. I get negative 29 over 24. And the absolute value of that is just 29 over 24. Okay, so we kind of treat the absolute value sort of like parentheses almost. Our next problem is going to be 18 negative minus negative 27. So remember, you're putting a negative in between. This is going to become, so remember that negative 18 plus 27 would give me positive 9. And the absolute value of 9 would just be 9. And finally, the last one. So this again would be the subtraction of two negatives. So we're going to get a positive in between. Common denominator, this one, I feel like I have a typo here. So hold on. 32, 64, I believe. No, that's not right. 48, that should be good. Yes. I thought I had a typo, but I didn't. So I don't know why I did. Anyway, this would be multiplied top and bottom by 3 to make that a 48. 16 times 2 is 32. So times 3 is 48. This would be multiplied by 8 on top and bottom to give me 56. Okay. So once we do that, we can add 56 and negative 9, and we get 47 over 48 positive. And the absolute value of that would just be 47 over 48. Finally, the last set, and then I'll open up for questions. So we are doing the replacement, 9 times y plus 2 times z, and anything times 0 is just 0, minus 6 times 4 times 0. So that's all 0. So negative 27. So anything times 0 is always a good one. 425, so x minus 7y is going to give me 4 plus 21 on top, which would be 25. In the denominator, I get 0 plus 3 times 4, which would be 12. So the final answer is 25 over 12. And finally, 6 plus 5 times z, which is 0. So that whole thing is 0, minus 9 times 0 squared. Your answer there is 6. So it is 9:04, which means we're getting into our second hour, which is great. We're in our second hour. If anyone has any clarifying questions, please feel free to let me know. If not, I'm going to ask you to please have the next lesson ready, which would be 3. Maria?
Yeah,
I will post this. Go ahead.
Yeah, I wanted to ask about 401. How did you get this, I'm sorry,
Common denominator?
29? Like, how did you get the?
Okay, so again, the common denominator is 24.
Yeah, I got that.
Multiplying the top and bottom by 4, we get 20 over 24. multiplying the top and bottom by 3, we get 3 over 24. Negative 20 minus 9 is negative 29.
Okay.
Okay, so work on those sign numbers. I know I also promised you guys, just one at a time, guys, because it does overlap. That I would give you those sign number rules. I will write those down in a few. Go ahead, Deanna.
I'm sorry, for 425, the one we just did, the last one you just did. When you did the 7 times the -3, you made it a positive in the middle, but I thought we were just supposed to multiply the 7. I'm confused by that one. Can you just go through that one again?
So 4 minus 7 times -3 over 0 plus 3 times 4. When you guys multiply, I tell you to attach the signs. So a negative times a negative would be a positive.
Okay, I got it.
Yeah? Okay. And anyone else that still needs me, I'm going to leave this. I can always quickly pull this up. It's not that I don't want to answer all your questions. I do, but I want to keep on track. So guys, I will post those answers on Blackboard in the morning. You're going to see a lot of posting by me. So please keep up with it. All right. So here's the deal. This is lesson 3. There's a lot of slides here. So when I was looking through what I was going to do tonight, I decided that I would not want to rush this lesson. So this will go into Wednesday. On Wednesday, I will finish lesson 3 and I will also hopefully finish 4. If 4 has to trickle a little bit into Monday, no big deal. So your exam will cover lessons 1 through 4. It will be 25 multiple choice next Wednesday. And it will be very similar to anything we've seen here, but I will provide a review for you. I'll talk more about what I expect on your exam on Wednesday. I'm going to get through. So my goal tonight is we're going to work as much as we can. If we can get up to most of the multiplying, that will put us in really good shape for Wednesday, but we'll see how it goes. So this is just a little bit of reading. I'll just point some very important vocabulary out. A monomial, so the prefix mono means 1. Okay, so a monomial is either a real number or the product of a real number with variables. You do not have to memorize that definition. Knowing what a monomial is by looking at a term is the most important thing. So 8x is a single term. Negative 3x squared is a single term. Notice I'm saying single to represent 1. 7a to the 3b to the 6 is a single term. 9 over 17t to the 3 is a single term. So please understand that even if it has multiple variables, it is still considered a single term. It becomes more than a single term when we start to apply pluses and minuses between. For instance, if we had 4x plus 5. I don't want to get into that yet, but these are all considered monomials or single terms. Now, the number in front of the monomial is called the coefficient. You guys already know this. And it is the value before the variable part. I'm so sorry. I have students emailing me from during the day. Sorry. So for instance, if I gave you guys 7x, 7 would be the coefficient, x would be the variable part. If I gave you guys negative 13a squared, negative 13 would be the coefficient. If I gave you guys y squared, if there's no coefficient written, we understand that it would be 1. A polynomial is in one variable, and I'll explain what that means, is considered to be in standard form when the degrees or the exponents are in descending order. So let me show you what I mean by that with an example. This is considered to be in standard form because it is in terms of one variable. So that's what we mean by when it says in one variable. And all of the exponents are in descending order. I'll give another example. So this variable that we're in terms of is y, and every exponent is in descending order. So if you saw something like this, this is not in standard form because this 4 term, or the exponent with the 4, would have to be in front. And so we're basically just looking for our terms to be in descending order. This is not so much important in this class, but it's a good habit to get into for your future math classes, depending on what you need to take. The last piece of information, and then we'll really get into this, is the leftmost term of a simplified polynomial is referred to as the leading term when they're in descending order. So this would be the leading term here. This is the leading term here. And this is the leading term here. And whatever their coefficient is would be considered the leading coefficient. So for A, the leading coefficient, I'm just going to write out the words for A, would be 1, because that is the coefficient in front of x to the 4th. In B, the leading coefficient is also 1. That is the coefficient in front of y cubed. And in C, the leading coefficient will be 5. Again, I know I threw a lot of information on you guys, but what we'll do right now is we'll kind of test ourselves a little bit more by looking at our next 3 examples. So just some more examples to kind of summarize what I just said. So number 7x plus 1 is considered in standard form because the exponents are in descending order. This would be considered the leading term, and 7 is considered the leading coefficient. Number 2, 5x to the 2 minus 3x plus 1 is in standard form because the exponents are in descending order. 5x to the 2 is called the leading term, and 5 is called the leading coefficient. Finally, for the last one, negative t to the 5th, it is in standard form, by the way, because the exponents are going down or in descending order. Negative t to the 5th is considered the, the leading term, and negative 1 is the leading coefficient. So that is the beginning of the terminology. The first examples that I started with you guys are all monomials, the ones up here. Now we're going to start to understand when it's not a monomial. So a binomial would be a polynomial with 2 terms. Some examples: 2x plus 3, negative 4x squared plus 5x, 8y minus 7. I'm making them up as I go. Okay, so we can see that the terms are separated by the sign in the middle. Therefore, they are considered binomials. A trinomial is a polynomial with 3 terms: x squared plus 4x minus 2, y to the 4th minus y to the 3 plus 6. A linear is a polynomial with a degree of 1, and that can be any polynomial. So for instance, 4x is linear, 7x minus 3 is linear, 8y plus 5 is linear, because the exponent that happens to be the highest is an exponent of 1. And finally, a quadratic, the highest exponent would be 2. X squared is a quadratic. 8x squared minus 5 is a quadratic. 7x squared plus 3x minus 6 is a quadratic. So I'm going to pause here if anyone needs me to clarify anything, or if you just need to get some of your notes. You will never be asked on an exam what is a binomial, a trinomial, a quadratic, any of that. But this is important for you guys so you know the notation. Okay, you know the wording. So if I say a binomial, you know it's a two-term expression. If I say a monomial, you know I mean one. If I say leading coefficient, you know it's the number in front of the term that's in front. Okay, so take a few more seconds and then we're going to start to apply our knowledge a little bit before we get into the operations. And again, I was going to skip this when I first started teaching this, but then I thought to myself, why would I skip this when it's good information for you guys to know? Okay, so if any of you are ready, there are three things that you're going to do. You're going to write the polynomial in standard form. You're going to find the leading term, the leading coefficient, and the degree. Now, the degree is the highest exponent. So let me demonstrate what I mean with an example. So let's make up an example for this just for you guys to see what I mean. So 8x to the 6th plus 9x to the 8th. Okay. So the first thing I'm going to do is write it in standard form. 9x to the 8th plus 8x to the 6th. Remember, standard form means that the exponents are decreasing. The next thing that I'm going to do is I'm going to write down what the leading term is. The leading term would be the front term, which is 9x to the 8th. The leading coefficient, which I'll write LC, is 9. That's the number in front. And the degree is the highest exponent, which would be 8. So hopefully that now clarifies. So let me give you guys about 2 or 3 minutes to work on A, B, and C. And if anyone needs me for anything else while people are working, I'm fine with that. Okay, so it's 9:17 by 9:19 or so. I'd like to do those. And then we'll get into our first operations. Just as a heads up, if you came in late, homework number 2 will be due on Wednesday. Okay, so please get that in, before that. I'll probably go over the homework right away, so please be here on time. Pretty much everyone here was. You guys are amazing with that. Just a reminder. Okay, so take a few more moments. I'm also going to see, I believe I had a YouTube channel when I taught this class before. I have to see if it's still active. If it is, I'll email it to you guys. But a lot of that has my, you know what I'm going to do? I'm going to stop sharing for 1 second. And I'm just going to see if I can find that. So just bear with me a minute. I'm going to see if I can find that YouTube channel. If I can, I'll share it with you guys. So take another moment or so. I'm just going to look quickly. And again, if I can't find it tonight, I will find it for you guys on for Wednesday. If it's even still active, I don't even know if it is or not. But we'll see. All right, you know what? I'm not going to waste time doing that now. I'll make a little note. If that is still available, I will share it with you guys on Wednesday. All right, so let's see how you guys did with these. So first, we're going to write it in standard form. So 2x plus 7, the x has a 1, the 7 does not have an exponent. So the leading term, I'll write LT, is 2x. The leading coefficient is 2. The degree is 1 because that is the highest exponent. Letter B, in standard form. So the leading term is 9a squared. The leading coefficient would be 9, and the degree is 2. You could also maybe write for letter B, it's a quadratic trinomial. It is a highest exponent of 2, and it is a trinomial because it is 3 terms. Letter A, if you want to write it in, was also considered a binomial. Finally, for letter C, 1/3 negative x to the 6th plus 8x squared plus x. So that's your standard form. Your leading term would be negative 1/3 x to the 6th. Your leading coefficient is negative 1/3. Your degree is 6. And this would just be considered a trinomial. It is not a quadratic trinomial because it does not have a highest exponent of 2. The highest exponent happens to be 6. Question, go ahead.
I just want to ask, is this going to be on the test?
Again, as I mentioned before, anything that I teach is fair game, but this is normally not asked of you on the final.
Okay, thank you.
Addition and subtraction of polynomials. So this is our first operation of 4 operations. When I say operation, I mean addition, subtraction, multiplication, and division. So 2 or more monomials are considered like terms if they have the same variable with the same exponents attached. So these examples are worked out for you. 8a and 2a are like terms because they have the same variable and the same exponent. So through addition, we can add the coefficients and keep the variable part as is. Letter B, we have x to the first and y to the first on both terms. So the xy part stays the same. And then we combine the coefficients and we get negative 4xy. Letter C, we have x to the 5th and y to the 2 on both terms. Therefore, we keep the x to the 5th and the y to the 2, and we simply subtract negative 6 minus 19 to give me negative 25x to the 5, y to the 2. So once you determine that your variable parts are the same, including the exponents, you're only dealing with the coefficients. Finally, s to the first and t to the 2 on both. So we can identify that they are the same terms. And then it's negative 15 plus negative 19, which is negative 34 st. Just keep in mind that if you had something like this, these are not like terms because the s on the first term is raised to the first power, but to the second on the other. And the t to the is raised to the 2 on the first, but the first on the other. So please be careful going forward. So what I'm going to ask you guys to do is to try these exercises. I will tell you that once you determine that these are all positive, you may drop out your parentheses. It's when there's another sign in between that we have to be careful. So why don't you do 2 things here? Why don't you guys go and combine these, simplify, and then also please make sure to write your answer in standard form. Okay? By the way, this homework will be due on Monday. The one for 3, I believe I posted it in case anyone did want to get it started, but just a heads up there. So I'll give you guys, this shouldn't take you very long, about 3 minutes tops. And again, if anyone needs me in the interim, please feel free to let me know. Okay, it is about 9:23, so just a heads up on the time and where we're at. Okay, we're on page 2. I hope the notes are helpful for you guys also in your, keeping things somewhat, consistent. Okay, so about 2 minutes. These are always good times to ask your questions too when I am paused and you guys working, so that's always another opportunity. I'm just going to start to drop out the parentheses for you guys. So if you notice, I'm just dropping the parentheses because plus does not affect us. It's minus that does. Okay. All right, so I want to get started even at least on the first three, just to make sure everybody's good. So again, once you establish that you have plus, you can drop out your parentheses. Combining the like terms, so 3y and negative 2y would give me 1y. And then 11 and 2 would give me 13. So again, like terms have same variable and same exponent. The second one, so 9x to the 2 and 2x to the 2 would be 11x to the 2. Next like terms are negative x and 7x. By the way, anytime you see a variable with no coefficient, the coefficient is always 1. So that would be negative 1x plus 7x, which is positive 6x. And the last like terms would be 8 and 13, which is 21. Okay, and again, guys, I would box in my final. Letter C, so the first like terms are 7x squared and negative 1x squared. So that would be 6x squared. 6xy minus 10xy. So you're just dealing with the coefficient and keeping the variable part as is. Negative 4xy. And negative 2y squared plus 12y squared gives me 10y squared. So I'll give you guys a moment to catch up and finish the next two. And then if you guys are good there, we will go to the last two and then move into our next operation. So I'm just going to slide up a little bit here. Okay, so by the way, one of the strategies that's always helpful is to start with the highest exponent. When you have two variables written, I would start with the single variable like a, then b, then ab. Excuse me. Oh, long day. Sorry. Aaliyah?
My question for the first one, how come it canceled out to y?
It didn't cancel out to y. It's 3y
Uh,
plus negative 2y. So it's the same as 3 minus 2, which is just 1y. You can write 1y, but you would never see an answer have 1y in it at the end.
okay,
Cool.
thank you.
You're welcome. Next one. So now we have, I'm going to start with my a squared because that would be my highest exponent. I only have one term with a squared. And by the way, you can also cross them off as you use them if that helps. I'm then going to go to my a terms. So I have a 4a minus an 8a, which is a negative 4a. 4 minus 8 is negative 4. I have an 1ab with a minus 6ab. So 1 minus 6 is negative 5. And then I have just a single minus 2, and that would be the appropriate answer. And the last one, I have only one x squared term, so that will stay as is. I only have one x term. And these, by the way, are considered constants. So negative 10 minus 2 would be negative 12. Any questions before we move to our next operation? Okay, I'm going to give you guys two ways of thinking about how to do this. And then I'm going to give you what I think would be the best for you guys. The other day we discussed the additive inverse. That was last week. So the additive inverse means to negate. So for instance, if I have 7x, the additive inverse would be negative 7x. If I have negative 8y cubed, the additive inverse would be 8y cubed. The problem becomes when you have more than one term. So when you have more than one term, you must negate, I'm going to write that word, all terms. So if I start with 8x minus 5, the additive inverse would be negative 8x plus 5, because not only will I negate the 8x, but I will negate the minus 5. So negate means to go opposite the sign. If it's plus, it goes minus. If it's minus, it goes plus. For the second one, if I negate or find the additive inverse, negative 6x to the 2 becomes positive, 8x becomes negative, and negative 1 becomes positive. So one of the strategies that so why am I showing you this? Well, this is what you guys would use for subtraction. And what's really happening here is you are distributing or giving out the negative to each term. This thing drives me crazy. Okay, to each term. So why don't you guys try A, B, C, and D? I can zoom in a little if you'd like. There you go. And then after we do those, we can then see why we would want to learn this and how it can apply to our subtraction. I'm going to keep you guys for a bit longer. I would like to at least get the multiplication going. So it is still rather early, which means I'm going to do that. So please, if you need to stretch or anything like that, if the screen's becoming a little much, take that time for yourself. But I don't give a break. So if you need to take one, you can, but I'm just going to continue straight through and give you your break at the end. So just so you know. Okay, so about 30 more seconds. And again, you're distributing the negative to each term or you're negating each term sign. However you want to think about it, it is the exact same concept. For letter A, that's an easy one, negative 5x. For B, the 3x squared becomes negative, the 2x becomes positive, the 1 becomes negative. For letter C, the 8y, 8 of the 2 becomes positive, the 7ab squared becomes negative. And for D, the x squared becomes negative, the 3y becomes positive. So this skill that I'm showing you guys right now is the skill that you guys will apply when you subtract. You can negate all of the terms by distributing. And when we add, we are using what we call, or subtract, we are using what we call the additive inverse. So let me demonstrate into our subtraction. If you guys have 12x minus 3 minus 5x minus 7. So unlike the last examples where there was a plus in here, I now have a minus. So I do not want to just drop out my parentheses, but what I need to do is I need to distribute or find the additive inverse of the second polynomial, or the 5x minus 7. So the first polynomial will stay as is, 12x minus 3. And then the negative goes into the 5x and becomes negative 5x. And the negative goes into the 7 and becomes positive 7. And that's where my parentheses can drop. I would then combine my like terms. So 12x minus 5x is 7x. And negative 3 plus 7 is 4. Now the other approach is drop the parentheses on the 12x plus 3. Make it a plus, that's additive, and then find the inverse or change the signs of the second polynomial, and you get the same answer. I personally like the distribution better, so that's going to be the way that I tend to teach it to you guys. So I'll keep going. Letter A, I'm just going to work through them before you guys try. So again, I have a minus, so this would become negative 2y. And this would become negative 7. So we would end up with 5y plus 3 minus 2y minus 7, which when we combine our like terms gives me 3y minus 4. For letter B, the first parentheses can drop. I'm going to distribute, so negative 3x squared plus 7x minus 2. And when I combine my like terms, I get negative 9x squared plus 11x minus 11. For C, I'm going to keep the first polynomial as is. I'm going to distribute the minus, so that becomes positive 8a squared minus 2ab, and then plus b squared. And when combining like terms, I get 18a to the 2 minus 3ab plus 13b squared. Finally, the last one, so I'm going to drop the parentheses on the first. I'm going to distribute the negative, so 9s to the second becomes positive 3s minus t to the 3 and minus 7. And when combining like terms, and I'll leave it to you guys, this is not necessarily in order. It's not in standard form, but that would be your answer. If you do want standard form, it would be 9s squared plus 17s plus 2st squared plus or minus 11t to the 3 minus 7. Don't worry so much about the order with that one. And again, that would be one that really is a lot more terms than what you guys would probably normally see. But again, it's more about the distribution of the negative and the combining of the terms. So I can always scroll back up here. What I'm going to ask you to do is I'm going to ask you to do the first 3. If you know how to do 4 and 5, go for it. I will say that as a hint, use this to help you. So subtract 4 from 10 might guide you a little bit in your setup. And then you can try 6 if you'd like. So I'll give you guys a few minutes, but 1, 2, and 3 should definitely be the ones that you guys can do without me. So please start those up. And then if anyone needs me for anything, I'm happy to help at this point. Okay, we're going to start a little bit of multiplication after this. And wherever I finish off, I will just pick up with on Wednesday evening. Okay, so please, if I don't finish tonight, just really review everything up until that point. I'm probably going to keep you guys for a good 10 to 15 more minutes at least. So just a heads up there. I'm sorry, but it is till 10:10. So just so you know. All right, let me shut up if anyone needs me. 9:37, I'm going to start at 9:40. Okay, so take your time with it. Okay, so about 2 more minutes. You should at least get through the first 3. If you want to wait, you could also do number 6 without me. Okay, so about another minute and a half. Just gonna see something quick here. Okay, so let's see just how you're doing on the first 3, just to check on you. So again, we note that it's not plus. If it was plus, we could drop right away. So they're the terms for the first. We can drop that. This becomes positive x. This becomes minus 11y. 9x plus 1x is 10x. 2y minus 11y is negative 9y. For number 2, negative 8a squared plus 3ab minus b squared. Again, we're going to note that it is not plus, so this becomes plus 3a squared plus 6ab. So all I'm doing is changing the sign, minus 11b squared. So negative 8a squared plus 3a squared is negative 5a squared. 3ab plus 6ab is 9ab. Negative 1b squared minus 11b squared is negative 12b squared. And by now, you really should be recognizing the common terms, the like terms, in order to combine them. Finally, number 3, so we can drop the first parentheses. We can distribute, so this is going to be negative 3s squared minus 8st plus 2t squared. So there's an s squared and a negative 3s squared for a negative 2s squared. A negative 5t squared and a 2t squared would give me a negative 3t squared. So let me get rid of that plus not to mess you guys up. Okay. And then we have a negative 8st. I think that's the only one we have. And if you want to cross them out, that would be helpful. So those are the first 3. And now I am going to drop to number 6, just so you guys can see when you have 3 of them, and then we'll talk about 4 and 5. So the first binomial does not matter. This, if it was a plus sign, we could then drop the next, but because it's not a plus, we will distribute. So that becomes negative 9b squared plus 12b minus 10. And then because there is a plus here, we can drop the parentheses. So basically, if there's a plus in front of the parentheses, we can drop. And if there is not, we would have to then negate or distribute. We're going to start with the b squared term. So there is a negative 6b squared. 5b and 12b is 17b, plus another b is 19b. And then negative 10 minus 5 is negative 15. Now, for 4 and 5, we are going to subtract 4 from 10. So if I say to you guys, subtract 4 from 10, you would really think 10 minus 4. So subtract from means that the second polynomial would come from the first. So we have 3x squared minus 8xy minus 6, and then minus 4x squared plus 12xy minus 9. Now, why am I using parentheses? Because it says subtract. If it said to add, it wouldn't matter. But because it says to subtract, I have to do my distribution. So the first set of parentheses can drop because there's a plus in front. And now I will distribute my minus into my second parentheses. And when I combine my like terms, I get negative x squared or negative 1x squared. Oh, I'm so sorry, guys. Minus 20xy plus 3 as my answer. Okay, so you guys can try 5 now if you didn't have a minute, but that would be how we do it. Yes, Julia.
Hi, good afternoon. I somehow has more exercises.
Yeah, I actually edited this because of time. I took one out of each one. You probably printed this earlier. It's the same concept, but I knew that I wasn't going to be able to finish everything. So if it has one more, it's no big deal.
Okay.
All right. Yeah, I did that kind of like after I decided to post it. So number 5, we can do down here. I'll give you guys another minute. So 5 would be over here. So take another moment. Okay, so the next one is going to be where we have another subtract from. So here we're gonna do the 9a squared plus 16 minus the 5a squared minus a plus 6. Again, parentheses because it says subtract and then from. The first set of parentheses can drop. We will then distribute, so minus 5a squared plus a minus 6. The 8 squared terms will combine to be negative 14a squared plus a plus 10. Okay, so we've now knocked out 2 of our 4 operations. We've learned how to identify leading coefficients and all of that, and of course, how to combine our like terms. Just be careful with the negating, and the subtract from means the second comes before the first. So I will pause to let you guys catch up. I would like to talk about one more piece before we end today, and then we will pick up where we left off on Wednesday. So you guys already know how to do this because this really deals with the exponent rules. I'll quickly summarize that when you are multiplying a monomial by a monomial, you will multiply your coefficients. And because you are multiplying bases that are the same, you will add your exponents. So you guys already know how to do this. For b, negative 7 and 7, a to the 2 and a to the 1 is a to the 3, b to the 5 and b to the 4, b to the 9. So you know this. Same with letter C, multiplying the fractions and reducing. And then again, multiplying bases that are the same, we add the exponent. So I'm going to say you guys already know this because this is all the exponent rules. This is an extension of that. But when we have a monomial, again, a single term, times a polynomial, we will use the distributive property. And you basically know the distributive property because you were just doing it with a negative. So let me demonstrate slowly. So this monomial will be distributed into each term here to drop my parentheses. So 4 times a is 32. A to the 2 and a to the 1 is a to the 3rd. And then 4 times negative 2 is negative 8. And then we attach the a squared. So 4a squared times negative 2 would be negative 8a squared. Let me just go through them all and then I'll open up for any questions. 5 times 5x squared is 25x squared. 5 times negative 4x is negative 20x. And 5 times 2 would be 10. So you're just giving out by multiplying. 2y times y squared is 2y cubed. 2y times 7y is 14y squared. And 2y times negative 2 is negative 4y. Finally, the last one is the trickiest, so I'll go really slow. So negative 9 times negative 5 is 45. P to the 5 and p to the 2 would give me p to the 7th. And then there's no other q term, so q to the 3. Negative 9 times 12 would be negative 108. P to the 5 and p to the 1 is p to the 6. Q to the 3 and q to the 4 is q to the 7. So you are still adding the exponents because you are multiplying bases that are the same. You're just giving that term out to everything in the parentheses. So I will take questions, but I'm sure some of you are ready to start. So what I'm going to ask you guys to do is let's finish. These will be our last problems of the evening. So let's finish with these and then I'll pick up on Wednesday with binomial. So why don't you guys take a few minutes to do these? We'll go over them and then I can clarify and wrap up with you guys at that point. So if anyone needs me, please feel free to ask. Okay, so I'll give you guys a couple of minutes. The first 3 should be relatively easy. Take your time. We're in a really good spot, guys. Excellent. Thank you for staying a little later. We're really in a good place for Wednesday, and I'll post all of this in the morning. Okay, so it's 9:51. I'm going to start by 9:54. So about 3 more minutes to do as much as you can. Okay, so about 2 minutes remain. Okay, about 1.5 minutes. Okay, about 1 minute remaining and we'll go over them. Okay, the last 30 seconds or so. Sorry, I'm just trying to update something for you guys. Okay, I'll give you guys another few moments just to wrap it up. Sorry, I'm just trying to fix something here. Just bear with me, guys. I'm sorry. I'll be right with you. Okay. All right. So let's see how we are doing here. So we're going to have the first problem, which is a monomial times a monomial. So we are going to multiply the coefficients and add the exponents. You guys should have got 10a to the 6th power. The next one is the same idea. So we're going to have a monomial times a monomial, 12x to the 5, y to the 10th. We are adding our exponents, and we are then going to multiply the coefficients. For the next one, you guys should remember how to deal with fractions. This is an M1 topic and pre-algebra topic. 2 and 8 reduced to 1 and 4. 21 and 7 reduced to 3 and 1. So we would be left with 3 over 4, x to the 6th, y to the 8th power. So A through C was all monomial times monomial. These are monomial times a polynomial, so we will distribute. I personally like to distribute right underneath. I think it's very helpful. So this would be what you guys should get for the first one. It's just a little easier to write it, and you guys can see what your answer should be. For your next problem, so we're going to do 14 p to the 3 q to the 9 minus 21 p to the 4 q to the 9 minus 56 p to the 3 q to the 8. So again, you're adding the exponents on the bases that you are multiplying. And the last one is 2 distributions. Let me just, I just need to fix something here, sorry. Okay, So the last one is going to be two distributions, and just because I wrote on that one, I'm just going to rewrite it so you guys can see. So it's the distribution of the 5y squared, and then the distribution of the negative 5x squared. So this would be 20y cubed plus 10xy squared minus 60y squared plus 10x squared y minus 5x cubed plus 55x squared. And I don't believe there are any like terms, so that would be the final answer. So I'm going to say this. I see a few people with their hands up, so let me just say a couple of things in case people are good and like to go. I'm stopping the